Okay, guys, so I want to talk about solubility graphs for just a second, then we're going to move on to colligative properties. Solubility graphs, we talked about solubility and factors that affect solubility already. Factors that affect solubility. So keep in mind this is not the same thing as factors that affect rate of solvation. And so as far as this, factors that affect how much can dissolve. So for solids, we said if we increase the temperature, we will increase solubility. So for example, if we throw salt in water or sugar in water and we want more of it to be able to dissolve, we can just increase the temperature. For gases, we talked briefly about these as well. If you increase the temperature, the solubility actually goes down. There's an inverse relationship there. And we talked about, I think in one of the earlier videos, a little bit about thermal pollution in lakes and streams. With the increase in temperature from some water discharge, we can have the oxygen content go down, and it can go down enough to harm the environment. But there's another one with gases. If we increase the pressure of a gas, we'll increase the solubility as well. And so this, an example of this is with your Coca-Colas, Dr. Pepper, whatever you drink. That bottle is packaged under a lot of pressure. It's almost 100 psi, if I remember right. And so the reason why it's packed under that pressure of it's carbon dioxide gas. That's the gas in that Coke, and it's highly pressurized. That bottle of Coke has a lot of CO2 gas pressurized in it, so that we get a lot of CO2 gas dissolving inside the drink. And then when you open the lid, you release the pressure goes down all of a sudden, so we get a down arrow, the pressure goes down, and the solubility would go down. And so a lot of the dissolved carbon dioxide that's in the Coke undissolves, if you will, and it bubbles out. And you see that, you experience that when you open up a bottle of Coke. And so make sure, I know that we've already talked about that one, make sure you know that the temperature and solubility for solid solutes, for things like salt and sugar, those solutes are solids. And for gases, things like carbon dioxide, oxygen, other gases. For the temperature, it's the reverse. And then we can also influence those with pressure. So if we increase the pressure, we'll increase the solubility. And so I want to show you a solubility table, because we'll use this on our tests and on some quizzes, and you might see this in some standardized test formats. Maybe not this exact chart, but a chart similar to this. And so again, whenever we deal with a chart or a table, the first thing you ought to do is you ought to be looking at what are we talking about. So here on the y-axis, we're talking about solubility. Here on the x-axis, we're talking about temperature. And so you can see here that the general trend on all of our solutes is that as the temperature increases, the solubility increases. And that's a general rule. We do have exceptions though, so you can see right here, here's an exception where we have a decrease in solubility for cesium sulfate, cesium 3 sulfate. But most of them increase. And so as far as we're concerned, all I'm going to want you to really do here is be able to read off a table. Simple as reading numbers. So I could say a question might be, what is the solubility of potassium chloride at 50 degrees Celsius? That's a simple little question. And so you would simply go to 50 degrees Celsius, find that line, run your line up until you find potassium chloride, which is this line right there. So right there, that's our point. Go over here, find your solubility. We are roughly, 42, maybe 43. So the solubility would be 42 grams, and this is grams of salt. And so the salt we're talking about in this case is KCl, potassium chloride. 42 grams of potassium chloride per 100 grams of water. So that would be our solubility in this example. If we had 200 grams of water, we could put 84 grams of potassium chloride in there, and it would dissolve. So that's one question that I could ask you with these solubility tables. I might ask you a question like this. I might say, if, let's say, let me look here real quick and get a number. Let's say if 40 grams of NaCl is placed in 100 grams of water at, we'll go with 40 degrees Celsius, what kind of solution is it? All right, so again, we'll go to 40 degrees. We'll hop up our line until we find the sodium chloride. And so this is the sodium chloride line right here. And so at 40 degrees, sodium chloride should dissolve. You know, do your estimation here. This is probably about 30, maybe 37 grams of salt could dissolve. So 37 grams of salt can dissolve. How much salt did we throw in that beaker? So if you put 40 grams of salt in this beaker, what would happen? Well, 37 grams would dissolve, and you'd have 3 grams here at the bottom undissolved. So what kind of solution is it? It would be a saturated solution. And so I may ask you questions like that as well. Just what is the solubility, or what is the solution as a result of these temperatures? So those are a couple kinds of questions that you may see with those. All right, so let's talk about colligative properties for a second, and this is where we're going to finish up today. Usually we would go a lot deeper into this, but we're going to keep it simple this year because we're a little bit pressed on time. We're going to eliminate the mathematical work for it. We'll see it, but we're just going to eliminate the need for actually working the problems. So a colligative property is a property that depends on how much solute is present, not the identity of the solute. So it doesn't matter what solute is present, it matters how much you have. So for example, it doesn't matter if it's sodium chloride or potassium chloride. It's how much is there is what matters. So the two that we want to look at, there's several, but the only two that we're going to look at this year is freezing point depression and boiling point elevation. And so they say exactly what they mean. So for example, if I had a beaker of water, pure water, then that pure water would freeze at 0 degrees Celsius and it would boil at 100 degrees Celsius. But if I took some solute, for example salt, and I put it in that water, then it's going to depress the freezing point and it's going to elevate the boiling point. So just throwing some made up numbers out here, if I threw some salt in there, maybe the freezing point would drop down to negative 109 degrees Celsius. Maybe the boiling point would go up to 102 degrees Celsius. It doesn't change by the same amount on both ends because the math constant's not the same, but the boiling point would go up and the freezing point would go down. This is useful in several ways. The freezing point is real useful in the wintertime when the road's ice. They'll throw salt on the roads and that salt lowers the freezing point, which allows that ice to melt. You also use it to make ice cream. If you make homemade ice cream at home, you use rock salt around the mixture to lower the freezing point of the ice and help the ice cream freeze. Boiling point elevation, you'll see that, for example, in a car radiator. The car radiator is what helps keep the engine cool, and you don't put pure water in it because the engine gets too hot. So you put antifreeze, which actually does both. It depresses the freezing point and raises the boiling point, and so the boiling point of the water in the radiator goes up to a lot higher number, and it helps keep the car cool. And so this is really all we're going to do with colligative properties. I like to usually go into this a little more deeper, but we're just a little pressed for time. We spent some extra time doing the stoichiometry, and so we're a little short now. So I'm going to cut this down a little bit shorter. So the three things I want you to know for colligative properties. Number one, the definition. What is it? So it depends on how much you have, not what it is. So example there, if I replaced the salt with potassium chloride instead of sodium chloride, as long as the amount was the same amount, the amount of salt equaled the amount of potassium chloride, the property would be the same. The change would be the same. Now, if I add more potassium chloride or more salt, then this number drops even further and this number rises even further. So there is a proportional change in how much you're adding to it. So know the definition of what a colligative property is, and then know what the two that I'm interested in this year are. So freezing point depression and boiling point elevation would be the two that I want you to know what they are. So colligative properties, know those.